All right, so this is a bit redundant, but we are going to learn some good new information. Remember, we said that P means negative log. So you take the P of anything, that means you're taking the negative log of something. So when we're talking about the pH, we're talking about the negative log of H3O plus or H plus. We can use them interchangeably. Or pOH is going to be then the negative log of the hydroxide, right? That's what pH and pOH mean. And remember that logarithm, so for example, log or x equals log base 10, that part's implied of y. You can reorganize this equation as y equals 10 to the x. And so you can see that these numbers right here, the x and the y, are related to one another. And so if we take a look at that, what that means for this pH stuff is we can say that the concentration of H3O plus or the concentration of H plus is equal to 10 to the negative pH, right? So you can go straight from the exponent to the concentration of the H plus. And same thing for hydroxide. The concentration of hydroxide is going to be equal to 10 to the negative pOH, right? So if you have a pH of kind of 5, then your concentration of H3O plus is 1 times 10 to the negative 5. So again, you don't really have to know these logarithms in deep detail. I won't ask you kind of super hardcore theoretical math-based questions, but it is good to understand it. And so as again we said as last time, as the concentration of H plus increases, the pH goes down, but then the pH goes up, right? Because the relationship between the H plus and the OH minus is fixed, right? And so same thing here again, as the hydroxide concentration goes up, the pOH actually goes down and the pH actually goes up. And so let's take a look at how this relationship is going to be very important to us to determine whether something is acidic or basic. So previously, we said that the Kw is equal to the concentration of the H plus times the hydroxide. And now we can take the negative log of both things. So if we take the negative log of both sides, we have the negative log of Kw equals the negative log of H plus times hydroxide. And then there's a property of logs that says if you have log of A times B, that's equal to log of A plus log of B. And so we can spread apart this H plus and OH minus. So we can say that this is negative log of H plus, and then it ends up kind of being, plus the negative log of hydroxide. You'll see why I kind of wrote that like I did in a minute. And then this remains negative log of Kw. If we go back up here, we just said that we defined pH as the negative log of H plus. And so we can change this negative log of H plus into pH. And then we have this plus. And then we defined our pOH as the negative log of hydroxide. And so we can take this negative log of hydroxide part right here and call that our pOH. And then for our log of negative Kw, we call that the pKw, right? Because again, P just means negative log, right? So we just took the negative log of stuff. Then we previously learned that at 25 degrees Celsius, Kw is equal to 1.0 times 10 to the negative 14. And so if Kw is equal to 1 times 10 to the negative 14, the negative log of 1.0 times 10 to the negative 14 is going to equal 14. And so we finally get an equation that says 14 is equal to pH plus pOH. And that's going to be true about any aqueous solution that's at 25 degrees Celsius. So you want to really know this. And again, this is kind of the same thing as the concentration of H plus times hydroxide has to equal 1 times 10 to the negative 14. This is stating the same thing, just in a slightly different way. Here our pH plus our pOH have to sum to equal 14.